Anne deposits $12,000 in an account paying 3% interest, compounded continuously. How much will be in the account after 8 years? Well, if we're compounding continuously, there's a special formula that tells us how this model works. And that's the amount in the account after interest is earned. So A equals P, which is the present value. So A is called the future value, P is called the present value, times E raised to the RT. And then E, of course, is the base of the natural logarithm, and R and T are the interest rate and the amount of time, respectively. So the amount in the account after 8 years, so we're looking for the future value. The present value is $12,000, and that's going to be times E raised to the interest rate of 3%, so 0.03, times the amount of time, which is 8 years. So we can put this directly into the calculator and calculate 12,000. I think that's too many zeros there. All right, times E raised to the 0.03 times 8. If you're using one of the older model calculators that doesn't show things as an exponent, just make sure you put in parentheses the 0.03 times 8 so that you get the same result, making sure the multiplier of 8 is also in your exponent. All right, so we get 15,254.99 when we round to 2 decimals. All right, part B, how long will it take for the initial account balance to double? Well, the initial account balance is 12,000, and it will double when it reaches 24,000. All right, so the future value is going to be 24,000. Then the present value is 12,000. Then e to the interest rate of 0.03, but now t will leave alone because we actually want to find how much time is going to pass. So that's why it's saying how long will this take. So we're solving for t. All right, so we have an exponential function that has a variable in the exponent. We are probably going to need to change into logarithmic form, but we can't do that until we have gotten the exponential by itself. So this multiplier of 12,000 needs to be divided away, and we're going to end up with a constant 2 over here equal to 0.03 e to the 0.03 t. Now, it's no mistake that this is a 2 because we're trying to get this to double. If you knew that right away, you wouldn't have to bother with the first step here, but I think this first step is a logical place to begin. But we do have a variable in the exponent, so we do need to change this into logarithmic form. So this is my exponential form of the problem. The logarithmic form is going to look like a log base, whatever the base of the exponential is, so base e, of the result of the exponential, which is 2, and then the result of a logarithm is an exponent, so that's equal to the exponent. Okay, now this next step, of course, a log base e we know to be a natural logarithm. So this is really the natural log of 2 is equal to 0.03 times t. And to get t by itself, I just need to divide both sides by 0.03. So then t would be equal to the natural log of 2 divided by 0.03. And if we wanted to know exactly what that was, we could use the calculator to approximate. So if we take the natural log of 2 divided by 0.03, it looks like we get about 23.1 years.